Hello, Rick Jacob and Kim Alards. Thank you for being here. We are going to talk today about multi-jetting in the world of 3D printing. I believe this is the future, unarguably the future of 3D printing in dentistry, allowing us to mix colors and mix resins. And so I'm really excited to chat with you both here today. Rick, I would view you as one of the godfathers of 3D printing. 16 years in the category. You were the founder of NextDent, and then you developed a printer and many resins, and then you sold to 3D Systems, and now you're on to your next venture, Novenda Technologies, which we'll get into. But I want to just start with what we have here. Rick, describe to us what we're looking at and just your passion for multi-material jetting in 3D printing.
Yeah, thank you, Rob. So, based on my experience, more than 16 years in the specific field, listening carefully to lab owners and technicians, I was already a long time convinced that there is an absolute need in the market for multi-material / multi-color aesthetic solutions by which labs can produce directly in one print a very aesthetic denture, including the base and the teeth, with different material characteristics so that we are really mimicking the old conventional way, using denture-based material in combination with pre-manufactured teeth, 3-4 layers, with all the 16 Vita colors, and now we are working hard to make that possible, to introduce that in the market throughout 2026 by Novenda Technology, based in Eindhoven, the Netherlands.
Fantastic. I love this. Multi-material jetting. I mean, the benefits are obvious. We're seeing here you've got, multi-layer translucency and multicolor, which is really cool. And Kim, your background was with, you said, 2D, two-dimensional color printing. So you have a lot of knowledge on that. And then three-dimensional printing now with Novenda. Maybe talk to us about your background and your passion for like color management and color printing, and how you're excited to bring that into the world of dentistry.
Absolutely. So thank you, Rob. I'm a physicist by education. I specialized in fluid dynamics. So after my PhD, I decided to work in 2D inkjet printing, which is also all about fluid dynamics on a very small scale. But then I realized soon enough that 3D printing, and in particular 3D printing for the dental market, is a much bigger adventure than the 2D inkjet market. So I decided to join Novenda Technologies, which has been a great adventure so far. And indeed, in 2D printing, there are a lot of studies on color management, on how to place all the droplets, all the tiny picoliter droplets, in very smart patterns so that everything looks very alive and natural to the eye. And I think it's a great challenge to bring that to 3D printing, where a lot less is known about all these color features and about how to address this topic. So I think that's one of the unique things we have to add at Novenda, is that we really have this background knowledge and that we can translate it to 3D voxel-based printing, and like that also realize these vivid colors and this realistic aesthetics in 3D printing of, in this case, the dentures.
This episode is brought to you by Rebel Crown. Are your dental crowns seated in minutes with flush margins and personal one-on-one service? If not, it's your time to rebel. The Rebel Crown is designed by your personal technician who you can call or text anytime. Milled with premium Harvest Nanozirconia, manufactured here in the USA with a 1-week turnaround time. Learn more at rebel3d.com. That's REBEL 3D.com.
Yeah, I want to lean into we're going to skip ahead to this slide because I think it's a nice transition. You have this, color palette that you can achieve. And so talk about that technology, the significance of it, and how it's so significant now in the 3D printing world. Because, well, yeah, I'll stop there and I have a follow-up question for Rick. Go ahead, Kim.
Yes, so indeed, you're spot on. So in 2D printing, you use these base colors and you mix them on droplet level, and then to your eye, you see the color that you want to see. In 3D printing, you use the same principle, but things, of course, become a little more challenging because it's in 3D. So you don't only have to think about the surface, but things also penetrate inwards. And then, especially in the case of teeth, for example, you also have to deal with translucency, which is also quite a complicated topic by itself. Because it also depends a lot on the background. Are you looking into someone's mouth? Are you having the denture in front of a light source or a window? So you have to combine all these effects to get to the right aesthetics. And you can use the same principles, but yeah, there are definitely much more challenges and things to take into account, which makes it a lot of fun for physicists like me and my colleagues.
Of course, and multi-material jetting. If we wanted to print many shades of pink for a denture, I think some technologies are like, okay, we'll have like 5 shades of pink or 10 shades of pink, and we'll just mix the different colors of pink together as we print. Maybe Rick, you could talk about why you didn't go that route, but you went this route where you have, cyan, magenta, yellow, white, and then T, tough, soft, support. Maybe talk us through your palette here and the significance of this palette and what you're looking to achieve with this palette.
Yeah, exactly. So the difference between our solutions and currently available solutions in the market is that we are working with way more jetting heads and 2 lanes. So in total, 8 heads per lane in terms of productivity, but also in terms of flexibility. Ultimately, different lab owners and different lab technicians have different preferences in terms of signature dentures and highly aesthetic work.
Yes.
So what we did was offering an unlimited solution, and then together with the customer, we will customize their preferences using, let's say, unlimited color and jetting possibilities, and then working in project teams managed by Kim and a couple of her colleagues in order to come to a signature standard which is perfect for the respective customer. And this is a completely different approach, and I think it's unprecedented. So we let the customer in the end decide what's the best solution for him, and we can set that as a standard into the workflow optimized printer. And when you take a look at previous solutions, there was one solution and you had to work like that, and that was it more or less, and then you like it or you don't, but ultimately addressing the market need in detail, specifically different, which is different country by country, but also segment by segment, makes this a unique solution.
Yeah, so the first 4 slots here is your color palette, 1 through 4. And then 5, 6, 7, and 8. Talk us through that. You have tough and soft.
No, it's translucency actually. So
okay, translucency.
And then tough material, soft material, and we can combine those as well. So for instance, when you would like to implement a soft layer on your denture, it's also possible to print that in one run. So the tough base, the aesthetic material for color for the tooth, and then in combination with the soft liner on the denture base, this is also possible with our solution, and that's not possible with any kind of technology currently used in the market.
So this is amazing. So the tough and the soft resins can also be shaded in different colors. So you could have a soft liner that's also pink inside of the denture, matching the denture base.
Exactly.
That is significant. I mean, that is really exciting.
Yeah, and Kim can elaborate a little bit more on technically how her team make that possible, if you would like to, Kim, because that's super interesting.
Yeah, it absolutely is. Yeah, so Of course, with the color management, we mix on droplet level in the right ratios, and we can realize any color or translucency level we desire or the customer desires. But you can have a similar approach for mechanical properties. So we develop materials with different kind of properties. For example, a soft flexible material or a very hard tough material. And by mixing them also in certain ratios and combining them with the colored materials we have, you can also not only vary your color, but also your mechanical properties, everything in between this soft flexible material and this soft hard material. And that gives you all the flexibility you want in designing and printing a denture.
This episode is brought to you by Des. Des is your one-stop shop for abutment solutions fully compatible with leading OEM implant systems. From tie bases and MUAs to the innovative direct-to-MUA screws and the new Des lock. Every solution is designed to streamline your workflow without compromising quality. Reduce chair time, cut costs, and restore with confidence. Do it with Des. Learn more at des-usa.com. That's DESS-USA.com.
This is truly a breakthrough. So exciting. I mean, it's very, very exciting for me to see this. So let's look at this is a cross section you have here of a tooth, and it's obvious for anyone in dentistry. Like, you take a cross section and you have different colors and different shades and different translucencies, and so we have to have a voxel design, right? Like for those that don't know, a voxel is like a cube, right? A pixel is a square in the world of 2D printing. A voxel is a cube represented in, is it a true cube in 3D space, or is it a
three-dimensional pixel actually?
Yeah. In our case, it's a cube. Yeah. Yeah.
Okay. So a 3D pixel. So talk us through, like, what are we feeding the printer in order to achieve this, gradient of color and translucency in the prosthetic?
Yeah, so we have, by voxelizing our model, we can really basically assign a material to each and every voxel. So we developed our own software to do that, because that's really a unique piece of software that didn't exist yet. We have some smart algorithms in our software that from the surface can determine where you want certain colors, how deep you want to penetrate this color into the object, where you want to start, for example, a gradient towards a different color, and so on and so on. So like that, you can really treat, for example, the different parts of a teeth separately. So you can have your dentin in a different color than your enamel. You can add a translucent shell to your teeth that you can even vary in thickness. Also for your gum, you can pick your color, add translucency if you like. So by that unique piece of software, we can basically choose per voxel what we want it to look like.
That is amazing, and we should acknowledge that the current world of CAD design software like 3Shape and ExoCAD and others, it's all point cloud. It's really a shell, right? And there's no voxel information internally in 3Shape design or ExoCAD design, and these point cloud designs, these STL, it's really a shell of an object. And so you guys are like light years ahead with this technology. Have you spoken to some of the CAD design software companies for them to start catching up with the innovation that you guys have here?
Yeah, for sure. So we understand that the mass majority of the market is currently using those kind of design software packages. We would like to establish a trusted connection, and we have discussions with them. However, besides that, we want also to implement that in our CAM software Voxelizing solution by adding a functionality that making realistic colors. We are not dependent on a third party in this perspective.
Yeah.
Although we are open for partnerships there, but ultimately we believe that working on a solution by ourselves will make our solution unique to the market and really bring a solution to the end customer, large labs, to offer them the possibility working with our algorithms and our CAM software in such a way that their output is predictable continuously.
I've heard of some companies, in a similar situation, creating libraries. So like in the world of a denture, you could have tooth libraries, and in those tooth libraries, you could have preset color schemes with different translucencies or mamelons or colors and all of that. If you do that, that's great because it's just a pre-selected library. So that's a great starting point. But if somebody wants to really be like the digital ceramist, right, and they're in there with a mouse or a brush on one of the fancy tablets to design the actual mamelons themselves and maybe some crack lines or some other characteristics, is there any software available today that you know of that would allow the digital ceramist to design in a voxel-based world? Like, does that technology even exist today?
I don't know, actually. We are working on it ourselves.
Okay. You are?
Because we see that there is a need. And we also understand that a lab has to be very productive. So letting all the technicians design using palettes and brushes and stuff like that ultimately will not lead to a very productive solution. So what we are currently thinking about is to establish project teams from both sides, from our side, from the customer side, in order to come to that perfect solution for them using different kind of libraries, and then set that as standard into the CAM software so that the vast majority of the production will be automized, clicking on certain kind of libraries and standards implemented by the project teams into the CAM software. Ultimately also give the opportunity and the solution there to make changes as time goes by, but that always will be an exercise by project teams from both sides. So it's a combination of full flexibility in terms of aesthetics and highest possible quality, but also taking a look at productivity as well.
There's a good point there, Rick. Highly productive labs, they're not going to want lots of people, painting with brushes inside of software, right? They're going to want a few libraries, maybe libraries that they custom develop that has their signature touch, but maybe it's 10 libraries or whatever, 15 libraries, and they just use the same libraries over and over again. So that would be the highly productive lab. And then maybe a few small niche labs that are trying to distinguish themselves as the digital ceramists. They also have a solution too. They have access to technology that could, reproduce their imagination inside of the software.
Yeah, Kim, you would like to?
I think you're spot on. So indeed, for a highly productive environment, we should work with libraries or presets. But in the end, having all this flexibility and giving details with a brush is, of course, a great opportunity. And I know our software guys also love to think big and love all the opportunities they see with the software. So that would definitely, our software is at least written in a flexible way. The architecture is very flexible, that also these kinds of inputs are possible. And like Rick said, we're also working on this part ourselves to make sure that we are also offering these kind of solutions. Yeah, so I think there are two different ways to approach it. Yeah.
For your design software, are you going to make it cloud-based, or are you going to make it locally install-based software? Any decision on that?
I think in the beginning, the latter. You installing a server locally, and we will see how it will evolve. As we are going to talk about the printer further on, in you will see that it is not a cheap small solution. It's really for the highly production environments, the large labs in the market, and we believe that a server there is also very safe for them as well as for us. But maybe in the near future, talking about 2-3 years from now, we are considering a cloud solution then as well. At the time we are addressing, let's say, a smaller solution to a specific market segment here.
That makes great sense, right? I mean, if and we'll get into the printer and the cost of entry and all that, but the large labs will adopt, and they don't necessarily require a cloud solution. But if they wanted to be a production center for maybe smaller independent labs around them that want to outsource the case to them, those smaller independent labs might want access to the software without having to, buy a server and all of that. So we'll get into that more later when we start talking about the printer.
Yeah, we will.
I wanted to show the palette here. And so you're covering all the Vita Classic shades. I mean, my guess is with the CMYW, not CMYK, right? Your CMYW color palette can produce really any type of tooth shade, right?
Yeah, and also unlimited. So we took the shade, the 16 shades, because that's the standard in the market.
Yeah.
But if you would like to differentiate a little bit between A2, A3, and you want to come there somewhere in the middle because you really like that color and you want to give it your own signature look, that's also a possibility.
Yeah, and I could see labs, producing their own shade tabs themselves from the printer that have the different levels of translucency, the different characterization that they have created in their library.
Yeah.
That's super cool. All right.
Yeah.
Let's take a look at a denture here. And so this is one that you've printed off your printer, yes?
Yeah, so this is taken off the printer and washed away the water-soluble wax. And this is then the quality what you see. So you see the translucency in the teeth slightly, but also you see the surface. So you will also save a lot of time in the post-processing. No more gluing base and tooth arches, no more polishing, washing away a lot of wax between the teeth, stuff like that. So it's a very clean, effective solution. And actually the only thing you still have to do is to gloss it, high gloss it. And that's a little bit a matter of minutes as far we are currently concerned. So a very efficient way of producing dentures, which was never possible before.
So there's no support structures like we're so used to seeing, right? Maybe talk about that. In your palette here, you have a support resin, and you said that is a water-soluble wax.
Yes, Kim, you would.
It's a water-soluble support material, so it's not wax-based, but it's a material that simply washes away in tap water. So it's very easy and low. There's hardly any post-processing involved to remove it. So if you really have the harder wax materials, you really have to do mechanical interventions to remove everything. And we don't have that problem because it washes away in water.
So when you pull it off the build plate, just talk me through it. Put it under some tap water, maybe with a toothbrush or something. Like, what's that process to wash away the support material?
What we do now is we unload the build tray, indeed, with the objects on it, and you can put it as a whole in a water bath. It will dissolve in time. Typically, what we do in our own lab is we add a bit of ultrasound to speed the process up, and then let's say in half an hour to an hour, your denture is free of support material, and you can continue the post-processing steps. Yeah.
So an ultrasonic water bath, no IPA.
No IPA, no.
That's amazing. Yeah, IPA, very flammable, very hazardous, so that's really cool. So ultrasonic, go ahead, Rick.
That was the idea also from the beginning. So we deeply take a look at the current manufacturing processes. In the DLP world, we are still experiencing the fact that post-processing is still labor intensive, but also a dirty way of working. And we would like to solve that problem by experimenting a lot over a long period of time with water soluble support materials to make the magic happen here.
So it's print it, wash it in a water bath with ultrasonic, and then can you just pumice and polish this like a standard denture? What's the final processing step to get it ready to ship to the patient?
Kim?
Yeah, so we do also a post-curing step for the final conversion, so for the biosafety.
Okay.
And after that, indeed, the polishing as you're used to. Yeah.
Yeah, a little bit less, I suppose, because normally we polish because in the old days it was a lot of plaster remains which we want to polish away. Then with DLP we had supports to the platform, but also bars preventing warpage, stuff like that. First you have to cut it away or trim it away, and then you have to polish those. But here we see that the surface is already extremely precise and flat. So based on our current experience, we are gaining a lot of time there compared to the current technologies being used.
You mentioned, post-curing and warpage. I want to talk about this. So when your printer is laying down the layers, is it also curing them in the process of printing, like semi-cure? And is there an argument for better geometric accuracy of the prosthetic from the source file to the final object?
Yeah. So yeah, we investigated all that. So indeed, there is a UV curing process in the printer for each layer. And the nice thing is that at Novenda, we developed the software, the printer, and the materials. So everything comes together. So we optimized, on one hand, indeed, the accuracy of the print process, where curing is an important factor. And on the other hand, of course, the biocompatibility is crucial. So there we developed our ink and our curing process in the printer hand in hand with the post-curing step to have both that right accuracy, but also the biosafety. Yeah.
Yeah. And okay, maybe also you can explain a little bit more in detail why jetting is so precise and so effective to come to a very precise part ultimately. And based on your experience, what is the secret of that technology compared to DLP, for instance?
Yeah. It again boils down to the picoliter droplets. So you have very tiny droplets. You can vary your layer thickness. You can make it as small as 10 or 20 micron. And also there, and that is also something that is very common in the 2D printing world. If you place your droplets in smart patterns, you can do a lot. You can win a lot in accuracy. And a colleague of mine, Ineke, who also has a background in 2D printing, she's really mastering this, and she managed to put the droplets in a certain way that we achieve a very high accuracy. Without needing to flatten or scrape each printing layers. So in other 3D jetting printers, you often see a roller or a plannerizer or something like that to flatten each layer to get the desired accuracy. But we are in full control because of these smart ways of placing the droplets, that we don't need that, and that we achieve our high accuracy. And we can even limit the use of support material because of this. So also it's very good for our surface finish, which leads to less need for polishing or a lighter polishing treatment in the end. So that's one of the secrets that we developed,
Okay.
and also one of the IP that we generated.
That's really, really cool. I mean, anyone that's done DLP printing of any kind, right? You print an object on a build plate and it's got supports on it, but it's still somewhat fragile, right? You can bend it or warp it a little bit if you're, not being careful with it. And when you go into curing, some prosthetics require like a T-bar to support it so that it doesn't warp while it's curing. And so, Rick, something I would love to see is an STL file of a denture, and then one of your printed dentures with a scan and then a heat map to see the accuracy. My guess is the geometric accuracy of your objects or your dentures are really high, which is huge for predictability, right? And then if the accuracy of the denture is really high and we're confident that it matches the STL file coming in, I think that opens up a world of model-free manufacturing. I'm a big believer that, digital models, right? The model of the mouth that we're so accustomed to producing to double check our bite, our occlusion, our fit. We don't really need a model if we're confident that the production of our device is super accurate, So what we see in the software, if we're confident that that is going to be perfectly represented in the output, then why do we need a model, right?
This episode is brought to you by Rebel Crown. Are your dental crowns seated in minutes with flush margins and personal one-on-one service? If not, it's your time to rebel. The Rebel Crown is designed by your personal technician who you can call or text anytime. Milled with premium harvest nanozirconia, manufactured here in the USA with a 1-week turnaround time. Learn more at rebel3d.com. That's REBEL 3D.com.
Yeah, no, fully agree. So I also predicted, let's say, within a couple of years, maybe 5, maybe longer, a little bit depending on the conservative side of the market, modelless will be the standard ultimately, because the only reason currently you're printing a model or you're using a model is to check your print. But if you are always precise and predictable, it's a waste of time. And
Totally agree.
so we have to prove to the market that it's always working and it's always according to the standards, which it is, and that's based on the smart jetting technologies implemented by our engineers. And actually, jetting was always used in different market segments outside of dental. For instance, jewelry, because for those kind of application, you need ultimately very, very precise details. And jetting was the other technology available to do so. And now we are implementing it in a different kind of way into the dental industry again, with a very highly productive machine. But we are using all those technologies to be precise and to be exactly accordance to the design files.
All right, you mentioned machines, so here's a picture of the machine. Maybe talk us through the size. And so this is the first version. Is this a prototype, or is this like a?
It's a demo printer, actually. It's
okay.
I would not call it a prototype. This is the printer we are going to install in our experience center in Eindhoven, where we can receive customers from all over the world, so that they really see the productivity on the one end, but also the ease of use and the printed part. Kim, would you be so kind to explain a little bit about the sizes, the details, stuff like that?
Yeah. So we really built a production printer that can print high volumes. And the size of the printer is about 2 by 1 by 2 meters. So it's quite a large printer, but it can also produce a lot of dentures or dental objects at the same time. So in total, we have 2 printing platforms that move in a very smart way, so that the printheads are basically continuously jetting on one of the platforms. And like that, we can in total print 32 dentures in less than 5 hours. So that makes it very efficient. And we also made sure that the printer is highly accessible. So in this picture, you see that the door is fully opened so that you can reach the printheads for cleaning, for example. You can easily load, unload your substrates. At this moment, my colleague Grigori is opening the ink drawer where the cartridges will go in. You can change your ink during printing. So by being in full control of the development of the printer, we made sure it's productive, it's reliable, but also very easy to use for operators.
So 32 dentures in 5 hours, okay. And then what's the human involvement with the machine to load the next set of 32 dentures? You just pull them off by hand and then start the next job. Talk us through, like, if I'm a high volume lab, how would I maximize production with that 32 dentures every 5 hours?
Yeah. So what we place actually a glass substrate on these two platforms, and you easily lock them in with a handle. In total, we have 4 smaller glass plates per platform, and we chose that so that your glass platform fits in all the standard post-processing equipment. We could easily change it to one big platform, but then you have to scrape your dentures off to fit it in post-curing units or washing units. And we thought that might not be very easy. So now you unlock your handle, you take off the glass plates, you can bring them to your post-curing process. In the meantime, you load your new substrate, you lock it, you press print, and that's it. So the loading and unloading is really something you can do. It's a matter of minutes, maybe not even. So it's a very fast process. On top of that, the machine will need printhead cleaning, but that's also very minimal. That's limited to probably once a day. And also that is a very easy process.
Is
So
that
that's
a
it.
manual printhead cleaning? Do I have to go wipe something, or is there an automated function where you press an operation and it cleans the heads?
It's a combination. So there is an automatic function that will make sure some ink is burst out of the printers, and then you have to do a manual wipe. Yeah,
Okay.
yeah, yeah.
And the changeover time, so if the 32 dentures are done, how many minutes of changeover time to load and print my next batch of 32? You
So
said
you really need,
minutes?
less than minutes. I think it's really release the handle, remove your platforms, put new
Put
platforms
new
in, lock
ones.
it, and you're good to go. Yeah,
So you just, pull the old platforms out with the dentures on it, put the new platforms in, press print, and then I can start post-processing my 32 dentures.
exactly. Yeah.
Wow. That's amazing. That is truly amazing. You had mentioned droplet size. Are you allowed to share how big each droplet is that is being laid down and cured as you're building the layers?
Yeah, so we're talking about a droplet size of tens of picoliter. And maybe it's easier to talk about resolution. So the voxel that you were talking about, the cube, or
Yeah.
that actually has a size of about 20 by 70 by 20 micron. So that is the numbers we're talking about. But also there, yeah, we are all
So
inkjet experts, so there are even options to vary that. But with this choice, we have the best balance between accuracy, between color mixing, and productivity.
so 20 by 20 microns by 70 high? Is that
No, the
the
height is 20.
arrangement?
So 20 by 70 horizontally, and then 20 high. Yeah.
Wow. 20 microns by 20 microns by 70. That is very precise, very small. That's incredible. Truly incredible. So the three-dimensional resolution is very high, 20 microns by 70 microns. That's amazing. Truly amazing. And so you guys are focused on dentures. Obviously, we've seen a lot of dentures. And then, Rick, I saw a multi-material night guard, so you can print in clear.
Yeah.
I'm assuming that's your focused prosthetics for the moment. You have any
Yes.
other prosthetics that you're innovating you can talk about?
Yeah, so we have a lot of ideas. For instance, partials, even aligners maybe one day. But currently this is what we already can do right now. And there's a huge need in the market for those two applications. Hard soft night guards, for instance, you see on the right. So you have a hard outer shell and a soft inner where the tooth are being connected with the night guard. And we believe that also there is a huge huge profit to make for large labs to address this market. And because of the fact that we are printing a gradient between the hard and the soft voxels, gradually, delamination, which occurred in the past, will now be forever prevented due to the fact that it can simply not delaminate anymore. You do not have any two different kind of layers connected to each other anymore. It's an integration now. And I think that's a big plus in terms of patient comfort, but in also addressing a new market solution towards clinics from labs. When you use the right marketing and the communication strategy around it, I think labs can increase their revenue rapidly.
Yeah, you talk about this transition from a hard material to a more flexible material. Like in the world of a flexible partial denture, we have this flexible base with hard teeth. And there's this immediate transition from flexible material to hard material, which we can understand. It creates a recipe for maybe teeth debonding or popping out. And so with your solution, you could have a more gradual transition from hard to soft, which is a huge benefit for strength and for prevention of, delamination.
Yeah, exactly. Or breaking off or getting loose or whatsoever. And that's something we saw in the real world happening all the time. So this will be prevented by completely out of the box thinking about new solutions, how to solve these kind of topics and issues.
That's unbelievable. That's so cool. So you mentioned you have a printer set up. So if I'm a lab, can I send you a denture to produce a sample? Like any access to the technology that's currently available today?
So this will be possible as from now, let's say around February timeframe. So in Chicago, we will launch this massively. I will give a couple of lectures there in conference rooms to promote it, and I believe from that moment it's perfect timing to receive design files and to connect project teams from the labs with our group, and then really understand the details and the needs, because we have to use our CAM application multi-material voxelizer to address the right translucency, or for night guards, how thick the hard and how and the soft, how many millimeters hard, how many millimeters soft, topics like that, which are not completely yet standardized. We have some ideas already, of course, but we want to use the lab to come up with their preferences, and then we will work on that. We will print it, and we can set it as a standard or as a library standard or whatever.
Unbelievable. So in Chicago, we should expect to learn more, see more, and hopefully by then a lab could send you a test file to just get a sample back to see what it looks like and how it behaves.
Yeah, exactly. That's the plan.
And what's the path for regulatory? We all know that's one of the gatekeepers of commercialization. Where are you at with the regulatory clearances in Europe or the United States?
Yeah, so both will take some time, of course, and also by sending over files and watching and using our demo printer. The printers are not yet ready for shipment, so we expect all of that to happen somewhere at the end of next year, at latest beginning the year after. But count on Q3, Q4, Q1, around that time frame. Another thing what we can discuss with the audience is to customize the printer according to specific needs of the lab. So if a lab based on their volumes wants to order this printer only for the production of night guards, we can scale it like that. Or let's say immediate dentures or try-in dentures. So the lines which we presented and the 16 possibilities, full aesthetic ultimately. That's also possible, but there are also other possibilities which we can discuss, and based on that we can act quicker and move quicker, maybe. But I would like to start up those discussions with potential customers beginning of next year, ultimately in resulting into printer shipments Q3, Q4.
Yeah, so if I'm a production center and I only want to produce dentures, you could optimize the machine and its capabilities to just focus on that one application. And so then what modifications would you make that would make it better for that specialized denture production?
Yeah, so if you want to, for instance, only produce immediate dentures, and you want to limit your colors by, let's say, only A2, A3, then ultimately in the end we only need 4 or 8 yet heads. Our yet heads are quite expensive, so you can save costs there, but also you can focus on production efficiency.
So cost optimization that's key, yes.
Exactly. Yeah. Yeah. And then ultimately the price per printed part is also lower then, and you are more competitive, or you make more profits. These discussions we would like to start as from Chicago.
Any indication on price point?
That's also we have different kinds of business models which we would like to discuss. We can sell the printer, we can customize the printer, so the prices then will be different. We are considering lease options, print per part fees, stuff like that. But ultimately, when you compare it with the DLP printing production, or before that the analog way of producing dentures, then we are more competitive ultimately when you take a look at the cost per printed part. So your initial investment is higher, but due to the fact that we are very productive, we can print at least 130 to 150 dentures a day, multiplied by 250 up to 350 working days. Then you know your volume on a yearly basis between 20 and 25,000, and then your depreciation over 5 years can be calculated per part. So the machine costs are not that high in that perspective. Materials also, we think we are very competitive, but the big saving is in the gluing base tooth arch, which is prevented. Labs are spending a lot of time on that, and the post-processing as well as the polishing. So when you measure that and take that in consideration, ultimately we believe that with this solution you can be more competitive and cheaper than with all the current solutions available in the market.
Yeah, the post-processing, if it's coming off the machine, pretty much done and ready to go, you don't have to have highly skilled and trained dental technicians to do the post-processing. You just have, highly productive people going through that process, which, there's savings there, right? If someone's not having to be highly skilled and highly trained to finish the dentures.
No, for sure. It should be as efficient and as easy as possible.
Wow. Amazing. Anything to say about as we wrap up here of what's coming next, or we're just focused on getting ready for Chicago?
For sure. That's the first plan. In the meantime, team is working hard to make the demo printer ready to receive customers in our experience center, and to set up project teams to discuss the details of the aesthetics, talking about signature, denture, stuff like that, to implement libraries as standards. And then we can talk business also with potential customers, and make a production planning for the shipments later on in the year. That's what we are going to address.
Amazing. So you'll have a booth at LMT or McCormick or both?
Yeah,
Where will
LMT.
you be based?
No,
LMT Chicago.
No, LMT. Yeah. And I will present in some conference rooms as well. I think it will be in the January issue of LMT, the program. I'm not yet sure exactly on which days I will be presenting, but that will be soon published.
Well, send me the links to those lectures, and I'll put them in the YouTube description, and people can look below and click on the link and make sure they save that time slot. This is going to be exciting to hear about.
I will do so.
Wonderful. Well, Kim and Rick, thank you so much for spending time with me. This is truly fascinating. I just have to wrap up here and just say that having a CMYW strategy for 3D printing is truly a huge innovation. And then even mixing the tough and the soft and the translucent. I mean, this is a breakthrough in multi-material jetting, and I think this is super exciting. This is the direction that we need to go. Now we just need the software companies, the design companies, to catch up and give us a little more creativity in the world of voxels as we design different prosthetics.
Yeah, no, we are open, and we would like to combine our mutual strengths in order to address this specific need in the dental market.
Absolutely.
Super cool. Kim, any final words?
No, thank you, Rob, for inviting us. It was a real pleasure, a really nice conversation. Heard some great ideas from your side as well. So I really feel the sky is the limit, and we're going to make it happen.
Awesome.
Yeah, thank you, Rob, so much for this opportunity.
Well, I'll be rooting for you guys, and we'll do this again in a few months when we have maybe some more breakthroughs to announce.
Yeah, and feel free to come over and to see it with your own eyes.
Oh, of course, I will. When will you have the first demo machine ready to show in the Netherlands?
Around February.
Yeah.
Okay. All right. So you'll be booking appointments for people to come
Yeah, we will.
see you. Okay. Yeah. Wonderful. I've never been to the Netherlands, so maybe I should come.
You should.
You're very welcome.
All right, guys. Well, thank you so much for the time. We'll be in touch.
Thank you,
See you.
Rob.
Thank you.
We'll stay in touch and see you in Chicago.
For sure. We'll see you there.